Okay, let's talk a little bit more about sound. Wanted to make sure you understood the difference between frequency and decibels when we're talking about sound. All right, so what I have here is just some typical examples of frequency and decibel for typical things. So frequency, we've talked about what frequency is. So in terms of sound, frequency would be, again, if this is a sound wave, how many cycles do I have from peak to valley? Or in this case, rarefaction to compression and back again. How many of those cycles per second? So just to kind of give you an understanding, we were talking a little bit about human hearing versus dog hearing. So humans, a typical range is between 20 to 20,000 hertz. And that can vary quite a bit. We talked about hearing loss, especially as you get older. Earlier in a previous video, I talked about how the ears work. So if you are subjected to excessive noise, such as earbuds, over an extended period of time, you can begin to damage the equipment in your ears. They just, they were not designed to operate at those high frequencies and amplitudes for that length of time. So you can begin to lose functionality of your hearing. So some older people, for example, might lose hearing on the high end. The high pitched sounds they may have a hard time hearing, but they can hear the lower pitched sounds easier. So this is the range over which most people are fairly sensitive, but extreme people with really good ears can hear down as low as 20 or as high as 20,000. Again, this is highly variable based on the person. On the other hand, a dog can hear on the order of 60 to 44,000. Again, that's going to vary quite a bit based on the dog and the geometry of his ears and his age and all that. But you can see a dog can hear a lot more than a human. That's why dog whistles are generally in this range here. So it's outside the range of that which the geometry of our ears will allow us to hear, but a dog can hear it. Interestingly, a cat can hear from 55 up to as high as 77,000, so a cat has better hearing than a dog does. Now here's a variety of different musical instruments. I thought it was kind of interesting to compare the different frequencies. And generally when you think frequency, we relate that to pitch in terms of music. I'm not a musician, but there's a guitar, so that would be a low frequency sound. That's a high frequency sound. And by the way, how do we get the different frequencies on the guitar? You'll notice that on a guitar the strings are all the same length, but if you look at them closely you'll notice they're different thicknesses. So we talked about how the natural frequency of a particular system depends on the geometry of the system. So in the case of a string, if I pluck this, it's vibrating at its natural frequency. In the case of this thick string, the natural frequency is lower because it's bigger, it's thicker, it's more dense than this one. Okay, so getting back to frequencies. So this is kind of interesting if you look at the different instruments. So a xylophone can provide a range of 700 to 3,500 hertz. Compare that to a guitar. So a guitar can go a lot deeper. That makes sense. If you've heard a xylophone, it doesn't go as deep as the low pitch sounds on a guitar. This is an electric guitar, by the way. A piano, much more restricted in the range of frequencies it can produce. A flute can go considerably higher. Again, that makes sense. You can get a higher pitch off of flute. I didn't put down a piccolo, but a piccolo can go even higher. A tuba, on the other hand, you know, tuba is bass, so it's going to provide a pretty low, deep sound. So these are frequency. Now this is not loudness. I can have a loud, high frequency sound, and I can have a loud, low frequency sound. So let's talk about loudness. Loudness is related to amplitude. So I'm going to get the same frequency off this string regardless of whether I pluck it gently or hard. The same frequency. You notice the pitch didn't change. Whoops. The pitch doesn't change. What does change is the loudness. And we measure loudness in terms of decibels. So So we measure loudness in terms of decibels. So loudness is amplitude of the vibration. Okay, so 0 decibel means there's no sound at all. 20 would be a quiet whisper. This is normal range. We talked about this in class. If you have something on the order of 85 decibels for an extended period of time, OSHA generally requires people to wear hearing protection because this will begin to cause long-term damage. Will you notice it immediately? No. But if you're constantly exposed to for hours at a time, day after day, 85 decibels or higher, you will begin to notice some degradation in your hearing. Some of your range of hearing, you'll begin to lose the sensitivity at either end in here. And then on the high end, obviously, if you're near Ellington like we are, and you're outside when the jet is taking off, it's pretty loud. And this is generally considered to be above the threshold of pain. That's why we tend to want to slap our hands over our ears when the sound gets too loud. And you should be wearing hearing protection. I should have put up here what the decibel is of a lawnmower or typical equipment that you would use around the house. But anyway, this gives you an idea. So make sure you understand the difference between frequency and loudness. I guess I didn't write loudness here. So loudness relates to the amplitude of a sound. Okay. Frequency is how many cycles per second do we have. And in terms of sound, we generally think of it in terms of pitch. So a high frequency sound is going to be a very high pitch sound to us, and a low frequency would be a very deep sound. Amplitude, this is just how loud is it. Be the same frequency, but it could be very quiet or it could be very loud. Okay, so let's go on to the next topic. We talked about sound. I'm just going to stop it a bit.